Und wir sind bereit, which is German for, and we are ready. So, what's up everybody? This is Ryan here, and you are watching episode 58 of my live stream Q&A. Decided to get a couple minutes head start on today's episode because I have a lot to ramble about, but nevertheless, I'll still be sticking around towards the end of the show for Q&A. So I'll try to have at least half hour of Q&A. But like I say, there's a lot of different topics that I wanted to discuss. And, you know, from time to time, I like to spend a little bit more time rambling on these episodes. And sometimes if I do a rambly episode, I'll try to just focus on a high volume of questions. But like I say, for today, we'll just see how it goes. All right. And as usual, the part of the show which I always used to forget, but if you like what I do and would like to support the WiseAss community in general, then please do consider supporting us on Google+, Facebook, Twitter, and also joining our Slack group, link in the description box below for all of those things. And on the Slack group, if you basically would like to have some help or feedback from a group of like-minded developers, at least like-minded in the sense that we all like to try and help each other and improve ourselves, then do consider joining. Also, obviously, you're watching this on YouTube in one format or another, so please do consider subscribing on YouTube and hitting the like button down below if you learned something today. Lastly, this is the part where I ask for money, but yeah, this channel is partly supported by donations from wonderful people such as yourself. So if you can't afford direct monetary support, that's totally fine. I do this stuff for free for people who can't afford to purchase learning resources for programming in Android. But yeah, if you do want to throw me a couple bucks on PayPal or Patreon, then links in the description box below. And like I say, if not, that's totally fine. And before we proceed, I would just like to thank the following people for supporting me on Patreon. So we have my good friend A, we've got Cameron, Graham, Hank, Pijak, Shoku, Sushil, and Trevor. So to all those people, thank you very kindly. Much appreciated. So, let's dive in here. Just have a quick look at the chat. What's up? We got Taha joining us again. And we got Al. And Homeless Hobo, I like your name. All right, and we got a question from Homeless Hobo regarding AAC's paging library, so I will mention that in a moment. Unfortunately, I don't actually have a great answer for you because that's actually not something that I've implemented recently, so we'll see about that. I'm actually working on dealing with the situation of parsing sort of large streams of data, and I do plan to basically create another Android best practices application. So I'll have a better answer for you when that application is done. In general, I really like architecture components. Unfortunately, like I say, I haven't been doing a whole lot of front-end work lately, so I don't know a lot about the paging library. But anyways, so two main topics. So just for announcements, a couple of things. Number one, I might as well start writing some of this stuff down. So big announcement, Kotlin 1.3 has been released. Yay! So I'm not going to go into a huge amount of detail because I haven't had a chance to review all of the changes. But in particular, I just wanted to mention coroutines are finally stable, which means that their API shouldn't significantly change from here on, at least not in the immediate future. So this was kind of met with mixed feelings for me because on one hand I was super happy that they are stable, but on the other hand it meant that I had to go back and do a bunch of, not a bunch, but a little bit of fiddling around in my code to get things working the way I wanted. So one of the things I'll be talking about today is discussing this process. I won't spend too much time on it because I know not everyone is Kotlin fluent yet. So second announcement is, sorry, let me just find my notes here. Second announcement is just kind of a, sorry, just give me one moment. I'm just going to arrange my stream software so that I can read my notes at the same time. Let's do that. That's a little more manageable. So announcement number 2. So some of you may have noticed I have been lacking for technical videos as of late. And I did manage to get up a couple of rambly, philosophical, esoteric videos, which were generally met with positive feedback. But, you know, if I did these things entirely for feedback, then I would be a very scared and confused human being. But yeah, the reason why I haven't been doing quite so much programming videos just in the past, I would say 2 weeks, I was doing pretty well, is I've basically had to drop pretty much all of my spare time to begin working on an application, which I was working on extensively over summer, and then unfortunately just due to our, it's an application I'm working with a couple of developers with, and we just had a whole bunch of difficulties, mainly due to time commitments. I was able to put in a ton of work on it at first for the back end, and then my ability to put any work into it whatsoever pretty much disappeared until the beginning of October. So anyways, longer story short, I've been trying to just work on getting that project pumped out as soon as possible. So unfortunately, over the next 2 weeks or so, that's probably going to be most of what I'm working on in my spare time. With that being said, I promise that in November I will be focusing more on video content. I actually have to, so pretty much regardless of what state the application is in. Hopefully we'll be able to get the application to a state where I can actually talk about it, but for the time being we're still pretty early in the development process, so we need to, I'm going to be waiting a little bit on that. But yeah, I've got that going on and 6 other bloody projects. So that's why I haven't been making too many technical videos, but don't worry, like I say, it will start up again in November, and I should be able to continue that for December. Yeah, so that's basically it for announcements, and we can get started here. Already a bunch of questions. Okay, so let's get the main topics out of the way. So topic number 1, and like I say, we will eventually get to Q&A, but for the first maybe half of this episode it will be discussing a main topic, and then also not really so much a question, but kind of like a discussion topic on interactors and use cases, which would be a kind of a fun thing in my view at least. So topic number 1, Kotlin Coroutines 1.3 and writing unit tests for them. So if you were watching my live stream coding last week, or the week before, sorry, I actually took last week off, then you would have noticed that I forgot to open up Catalyst ahead of time, so I'm just going to do that now. Just give me a moment. There might be a little bit of lag here. Oh, it actually loaded fine. That's a major surprise. Okay, so anyways, what was happening is, so 2 weeks ago I was working on basically getting set up so that I can run my unit tests with Kotlin Coroutines, and I was having all kinds of trouble with getting my result wrapper to work. I'll see. Oops. Alright, so hopefully I can undo it and show you what it looked like before. I'm not sure if it's actually... Yeah, that's not going to happen. Well, basically what was happening is I was getting an error just in this little section of my unit test. And I spent like a ton of time fiddling around with my result wrapper because I thought the problem is I just didn't have this result wrapper object set up correctly. And basically what the result wrapper is anytime you're talking to like a backend service or something which, excuse me, anytime you want to be able to represent a response from some portion of the application, which may be capable of representing different states. So one state could be data is successfully retrieved, the other state could be no data is retrieved, the other state could be an error, or the other state could be loading. So for example, I've got this result object here, and basically what it does, let me just get rid of that for a moment. Basically what it does is I wrap some function call, so this would be, I hate it when it thinks I'm clicking and dragging like that. So it wraps a function call to the backend, and if you're curious about this, ask in the questions and we can go over this in detail later. But it wraps some function call to the backend, and it'll either create a value, so some successful result, or it'll create sort of an error class. And so I thought I was screwing up the error somehow within my result class. What ended up being the case is I open up the repository. No, that's not what I opened. I open up the repository, iWorkout repository, and the mistake I had actually made is I had accidentally swapped these two. Oh, I can't type. There we go. Exception. So I believe if I go back to, yeah, so basically this thing was lighting up red like so, and I spent like a half hour trying to figure out what the problem was. I ended up casting it to something else, and that got rid of the, as my friend Mr. Malas mentioned, that got rid of the compile time error, or no, got rid of the pre-compile time error. But it wasn't actually a proper solution. So the solution was to just not screw up my either monad, which is the fancy functional programming word for a result wrapper. They like to use very annoying words in functional programming, which is a really interesting topic, and it's something I've been studying lately. Oops, what am I doing here? Exception and workout. But yeah, it's kind of annoying to learn functional programming because they love their jargon. They're all a bunch of math nerds mostly. I'm totally generalizing, but man, it's fun. Okay, so I fixed that issue, and then the way that I was able to get my coroutines testable. So for starters, if you want to, for example, test suspending functions, so that's what these are here. This is my interactor. If you want to test suspending functions, so suspending basically wraps this function into a coroutine is the simplest way I can kind of explain it to you. And how you can test those is you actually want your test class itself to use the run blocking coroutine builder. And very specifically, if you're testing suspend functions, you want to include a unit type parameter for the run blocking coroutine builder. If you're not sure, unit is basically Kotlin's equivalent to void. That's not 100% true, but it does map to void in Java. So yeah, just be aware that you're going to need to do this. If you try to test a suspending function without including that type parameter, you will get an error which says the name of, say, get workouts by ID. It'll say this function needs to return null, or sorry, void, and this is how you get it to return void in the generated bytecode. So if you're curious about that, you can check out the repository for Catalyst. Hopefully I have the link to the most recent version in the description box. If not, scream at me. And I did actually just do a commit, so you can check those tests out. Lastly, on the same topic, in Kotlin MVP Calculator, I went through and made sure that So I basically fixed all of the unit tests for the Kotlin Coroutines branch. So basically, Kotlin MVP Calculator, link in the description box below. It's an open source application with 2 branches. One of the branches is Kotlin with RxJava implemented. The other branch is Kotlin with coroutines instead of RxJava for concurrency. So if you're curious about seeing coroutines in action and unit tested in a tiny little well-built application, then check that out. I just did another commit to that. And just one last thing to note. So since the presenter I spoke about testing suspending functions, which are coroutines essentially, but one thing you want to do is if you're not testing a suspending function, but instead say testing a class which has its own coroutine context and dispatcher and all of this stuff, you can ask about that later if you're curious. You don't actually need to, where's my test class, use that unit type parameter there. Instead, what you can do, what I've chosen to do is I've chosen to actually inject the dispatcher class. Again, if you're not familiar with Coroutines API, you're not going to have any idea what I'm talking about, so I won't talk about this for long. But I've injected this dispatcher provider in the same way that I used to inject a scheduler provider for my RxJava stuff. And basically what that does is it confines this coroutine context, which becomes an extension of the actual presenter. What that basically does is it allows us to call this launch coroutine builder with this as, so this, it understands implicitly that this is an extension function. Notice how it's glowing kind of yellow here. It understands once you configure your extension, your property here. Once you do this, essentially, it's going to know that you can just call a launch coroutine builder right here, and then we just specify the coroutine context, the scope that you want to run it on. And so when I call this particular method in the working application code, it will actually supply the coroutine context. Let me just pull that up, dispatcher. So it's going to either, just like RxJava schedulers, if you're familiar, it's either going to supply the main dispatcher or the IO dispatcher. This is also, I guess, equivalent to UI, more or less. And then when I want to run my unit tests, in order to do that, I actually mock that object. So I've got a mock dispatcher provider. And then it, when I create the presenter, it just kind of swaps out the dispatchers.main for dispatchers.unconfined. Again, this is pretty much equivalent to schedulers.trampoline. If you're used to unit testing RxJava, you needed to use the trampoline scheduler if you wanted to actually test it in unit tests. So this is essentially the same idea here. If you do all that stuff, then you can have a super easy time writing your unit tests for your coroutines. And as you can see, I've got all the tests passing and everything is fucking wonderful. I'm just kidding, pardon my language. So, yeah, that's basically my lightning fast explanation of Coroutines 1.3. The main thing that changed, like I say, is so we used to provide this coroutine context thing here. Again, I can't even remember how I used to do it. You used to have to supply, yeah, you used to have to like supply some context object here, and then a job tracker. So this job tracker object is basically how I dispose of active suspended functions, how I get them to stop if I want them to stop. And there's a bunch of fiddling around you needed to do with some parameters. We don't really need to do that anymore as far as I'm aware. because we can basically just treat this coroutine builder here like an extension of the calculator presenter, and in particular this property here. So this is where we get the coroutine context from, instead of passing it in here, is basically what I'm trying to say. Yeah. Okay, cool. So that's my rambling about coroutines, and if you're curious about that, feel free to ask questions and check out the source code. It's all open source. Okay, so now we're just going to have a discussion about use cases and interactors. Do I have... Good, I do have it open. All right, so I know that was super technical. So the next topic is also pretty vague and technical, but it's more to do with software architecture. So if you're a beginner, again, ask me for clarification about anything I'm talking about here. But if you're a beginner, I would actually kind of suggest you listen to me ramble about software architecture for a few minutes, and don't try too hard to understand what I'm saying, because there's a lot of topics to discuss all at once here. But I'm going to get into some really interesting kind of material to do with interactors, use cases, and how to build a clean architecture. So this is a subject which is really close to my heart, but it's not something that I've been able to talk about a huge amount, or had the opportunity to talk about a huge amount. I can't English right now. Let's just get started. Okay, so first thing is first, let's just pull up a diagram. As usual, you know I like my visual diagrams. Okay. And so, topic number 2. So this topic was actually mentioned, or is actually sort of based on a question and conversation I had with Mr. Malas again, who has been a great source of excellent questions. So thank you very much. I appreciate it. So Taha asked, I'll just kind of paraphrase his question here. Is it not a good idea to talk to use cases / interactors through an interface in order to promote abstraction? Or essentially, is it not a good idea to have your use cases or interactors basically confined to an interface, or to have some kind of contract? So before I get into the really technical stuff, what I will do for the beginners is I'm going to talk about what I'm trying to do, hopefully in a way which is a little less complicated than what you're used to seeing. I'm not saying it's not complicated, but I'm going to try and explain architecture in a way which is hopefully a little easier to understand for people. So, simply put, I'm sure you're used to hearing about model view, view model. You're used to hearing about model view controller. You're used to hearing about model view presenter, all of that good stuff. You've heard the term clean architecture. What does that mean? Well, if I were to actually really boil down how I perceive the fundamental building blocks of an architecture, with the understanding that there's no perfect way to do it per se, then it would basically look like this. So essentially we have basically on the front end, whatever is your view. So this part is actually quite unambiguous. This is either going to be your data binding or your fragments. This is just user interface binding. I typically use fragments. I'm not a huge fan of data binding, although I know a lot of people are, and I'm not saying it's bad. But yeah, that's basically how that looks. And then we have what I would like to call a decision maker for the front end. So this will typically be like a presenter or a controller or a view model. And my going assumption here is that you will need some kind of object or software entity on the front end which is capable of making logical decisions. Now, because I am a huge fan of I was going to say the single responsibility principle, but that's not actually what I mean. Separation of concerns. I don't actually want my decision maker to be responsible for storing any kind of data, nor do I want my user interface class to store the data. So I also have a front-end data store. So you could think of this like, this is actually how I use ViewModel from architecture components and live data. I don't use ViewModel as a decision maker. Some people do. I wouldn't advise it unless you really know what you're doing. But yeah, that's basically my, pretty much my interpretation of what the average front end requires. Then we have the back end. So essentially what we're doing here, so I have a theory. My theory is that when you're building a complicated architecture, there are different boundaries you can make, but I think in many cases it's good to have objects, or actually I would say necessary, to have objects which make decisions both on the back end and the front end. So for the back end, we have the use case here. Oh, my jaw is clicking, that's annoying. For the front end, we have the use case, the repository, and the interactor, things of that nature. Again, it depends on how you define these things. And what we'll see in a moment is there's not actually necessarily super strict definitions of these things. And then you've got like some kind of decision maker on the other end. So the theory is these two classes will be where you focus your unit tests or your testing in general, because they're by definition the parts of the application which have most of the logic. And therefore, what I would suggest to you is classes that have a lot of logic really do need to be tested. If you're going to skip testing anything, skip testing and I'm probably going to get shit for saying this, but skip testing the simple things, like skip testing whether set view by ID works or not. We don't really need to test that. I'm not saying don't test your UI, I'm just kind of making a general point about how I kind of build and test applications. Okay, cool. So this is the basic idea here. Now, what we're going to be talking about specifically is this decision maker class here, or use case, or repository, or interactor. So we'll just make a couple of notes here. Man, I need a haircut. Look like Chewbacca from Star Wars. Anyways, here we go. So main thing, we're talking about clean architecture in general. So if you want like a general keyword to look up, we're going to look at clean architecture, and someone who's very good at explaining and basically has largely defined clean architecture is Robert C. Uncle Bob Martin. He's not my uncle directly, but we just call him Uncle Bob because that's basically what he is. He's every programmer's awesome uncle in a sense. So anyways, yeah, you'll want to check out work by him, YouTube videos, books. I have several of his books in my own collection, so definitely check that out. So the question is, we're talking about use cases and interactors, and one of the issues I have run into is that every developer kind of has a slightly different take on what a use case or an interactor is, and it's basically impossible to actually say who is correct. So what I'm going to do is, instead of talking about what is the best way to do something, I just want to talk about some discussions I've had with a few people and the way I kind of think about these things in my current applications. So at first, basically the way that I implemented use cases will be how you see them in my POS Trainer repository. Now this is an old repository. It's Java. I wrote it I think over a year ago, so this is not going to be, the reason I'm showing you this is how I used to do things. So if I have a look here, so you're going to see in the Project Explorer of PosTrainer, you're going to see I have a whole package loaded with these use cases. So I'll open a couple up so you know what I'm talking about. And they all have names which basically are simple operations. Further, and this is kind of one of the parts to Taha's question, is that they do actually all implement a particular base use case interface which looks like this. And back then, since it was Java and I didn't have my lovely coroutines, I had to use RxJava flowables. And then we also had like a completable if I needed a completable one. Okay. So what exactly is a use case in the context of this project? And this is how I've seen a couple people think of the term, or an interactor. If you're wondering what is the difference between a use case and an interactor, I don't know if there actually is a difference. It appears to pretty much point to the same concept. So all of these use cases pretty much conform to something which I'm going to want the application to be able to do. So we've got getAlarm. It's an alarm application. So we have a use case called getAlarm, cancelAlarm, deleteAlarm, setAlarm, startAlarm. And as you can see, I basically have a use case for every little thing that I want my application to do. And generally speaking, they'll only talk to one or two entities in the, or I shouldn't say entities, objects in the backend. So we're talking about these data sources. So we're thinking like database, network, sensors, etc. Or an alarm manager, so like a service. Do I have one that has multiple? I don't seem to have any that talk to multiple data sources. Oh, here we go. Okay, so so most of them you see this kind of one-shot behavior. So it's basically just we have some single thing we want to do, some action. We, delegate it to the back end, which is the alarm manager in this case. And then essentially what this use case, its main function becomes, is it's basically just an extra layer of abstraction over my alarm manager, which is already abstracted, if I'm not mistaken. If it isn't already abstracted, that's how I build things now. So in discussing this with my friends Davor and Darrell, and kind of thinking a lot more about in trying to figure out my own way to do architecture instead of just trying to base it off everyone else, we all kind of agreed that this might not actually be the best way to build these interactors, even though there are a number, I'm not saying people who do this are wrong, certainly not, but here's why we all kind of view, I hope I'm not speaking for them, but I believe what we kind of all agreed is that the problem with this little setup here is that if a use case only needs to talk to one part of the backend, then this class here, like I say, all it does is just an extra layer of abstraction, which isn't necessarily a bad thing, but if the backend is already abstracted anyway, then why do we bother with this extra domain layer? So that's one piece of information I want you to hold into your brain. However, some use cases or interactors do, where's the one I was looking at, actually need to talk to multiple different data sources in the backend. So in order to toggle an alarm in PosTrainer, not only do I need to basically retrieve the alarm in the database and then update the status of the alarm in the database, but I also need to either activate it or deactivate it using the alarm manager class, which is a system service. And this use case toggle alarm basically coordinates those operations. more or less. So as you can see here, we say update the alarm and then set alarm, just like so. So several of my friends who I was speaking of, Devor and Derel, I believe neither of them really have use cases anymore based on what you see here. And I basically don't really do these single shot use cases anymore. Why don't I do that? It's an extra layer of abstraction for possibly no reason. It creates this class explosion, which, listen, normally I don't have any problem with that because we're achieving separation of concerns. But if you look kind of closely, all of these different classes look almost identical. The only thing that actually changes is, say, the nouns. And that's kind of, you know, debatably a bit of an exercise in practicing my typing skills. If I were to actually try and do this in a larger application, I would, you know, feasibly end up with, say, as much as 50 of these little individual use case classes or interactors, and that just, you know, I'm not really into doing that. So what do I do now? So a more recent approach, which I've adopted, is the one I've been trying to build in Catalyst. I haven't had a huge amount of time to work on this application, but so far, so we do have a domain layer, and I've actually dropped the word use case this time, because to me a use case is, so this is my conjecture. I'm not saying you have to follow this convention. I think of a use case as one of these things, which means I don't really use them anymore. I do use them to kind of design the app, but as far as actual things like this, for reasons I just mentioned, I don't actually do this anymore. Instead, what I've been doing is I have what I call an interactor. I decided to call it an interactor instead of a use case because it's a group of use cases, essentially, is what it is. As you can see, we've got sort of the same stuff you would see, except they're all grouped together in one big interactor. So what I do now is, let's say we have some thematic, some domain model. So we've got exercise template, workout template, and so set is just part of an exercise, and exercise is just part of a workout. So what I've done is, for every sort of primary data model, I have an interactor for it, and it basically manages all of the different, for lack of a better word, use cases. As you can see, it hasn't been implemented, but it manages the use cases, say, for everything that comes in and out of the workout repository, and the same will be the case eventually for the exercise templates and all kinds of crap like that. So basically what I've done here is, instead of trying to have 50 individual use cases all in separate classes, I have, say, I don't know, 15 in one of them, and maybe 15 in the other, and then maybe 20 in the other, or something like that. And I find this is a little bit more manageable. I get far less of an explosion of classes. And as you can see, these interactors are still highly cohesive. They're all working on an exercise object. They're all related. So it's possible that I might eventually need to have interactors which have multiple data sources here, and so I might need to create special ones. But as my dad would say, I'll burn that bridge when I get to it, which is a joking version of the saying, I'll cross that bridge when I get to it. I feel bad that I have to explain these jokes, but I realize that a lot of people aren't familiar with random English expressions. So that's basically, yeah. So the question Taha had specifically about this is, shouldn't these use cases or interactors be spoken to through an interface? I don't think so, the way I'm building them here. So what these things look like when we actually want to interact with them, I'll hop back to Pos Trainer, and let's grab a presenter. So when I actually want to use these use cases, the old way I used to do it is I would basically inject them, as far as I'm aware. No, I would create them. Oh, wait, you're not, for some reason it's not advisable to do dependency injection in use cases. I think that maybe was just Robert Martin being a little bit picky about having frameworks in the use cases themselves, but I don't actually inject them. Or actually, no, this is dependency injection. I'm an idiot. I'm not using Dagger to inject them specifically. But yeah, I create them in the presenter, and I'm not suggesting you do it like this. This is my old approach. And then when I need to do something, I just call the bloody use case, and then we have all of our lovely RxJava chained method calls, which I'm sure we're all just so excited about. And so kind of the question is, should these be spoken to through an abstraction? I don't think so. And the reason why is twofold, and I did mention this to Taha in a message response, but I'll just summarize my thinking here. So, why not? In order to answer that question, let's think about sort of the main reasons why we would want to use an interface. Interfaces are great when you, actually let's say abstractions, because we could do this through an abstract class, are great when you need to swap implementations easily. So this is a truism of interfaces, is that they make it super easy to swap the thing which the interface implements. So when I want to test something, if it's an interface, I can just put a fake thing behind it, and then I can test the real thing based on that. Well, I don't really need that, because I have my mocking framework. So for example, let's go to this is Catalyst again. Let's go to a test. Which test? Workout interactor test. So as you can see, I actually just, where is it? No, I'm looking at the wrong application. Let's go to Kotlin MVP calculator. Okay, as I mentioned earlier, all I need to do when I want to, say for example, swap the implementation of the things that are passed into this presenter here, I just use a mocking framework like Mockito. In fact, this is a use case and I've mocked it. So that affords me the ability to swap implementations without having an interface. Secondly, let's see if I can remember what the second reason was. Oh, Jesus. Okay. Just give me a second. There was a second reason which my mind is absolutely blanking on. And don't worry, I'm almost done. We'll get to Q&A soon. Derp-de-derp-derp. Now I have to go look up my own response to Taha. That's what it was. Sorry, I had a momentary lapse. So this is reason number one, swap implementations. The other reason, abstractions/interfaces are great when you want to hide implementation details. This is actually, in a sense, the same thing as the above, but it's with a little different goal. So the problem with, say, is this Catalyst? The problem with, say, for example, having a presenter talk to this use case without an interface is that it might potentially have access to functions which it doesn't need. So what I'm saying here is not every presenter will need to use all methods of an interactor in order to do what it needs to do. There is a principle, I forget what it's called, where you're not, it's one of the solid principles, I believe, actually. It has to do with the, I feel like it's the interface segregation principle. Anyways, whatever, not overly important. But basically, if I don't use an abstraction, then I run the risk of presenters having access to functions which they will never use. Not really bothered by that. I know that's bad practice, but here's the thing. If I do choose to have this thing spoken to through an interface, a tailor-made interface for every individual presenter, then I will be basically doing a little bit what I did before, which is having a separate file for things which are thematically grouped together. So basically what I'm saying here is it's at the point where there is a trade-off, and this is kind of where I wanted to end this discussion on. So when I want to talk about this just for a moment, and then we'll get into Q&A, and I will shut up. So I wanted to just talk about principles. So something I mentioned to Taha, and this is something which I've heard senior developers say to me, is that developers usually go through a 3-stage process. And I have been through this several times with several different tools. So the first thing they do is they let's refine this a little bit, and we'll say developers usually go through a 3-stage process when learning principles. And now we're going to focus on this word principles in a minute because it's important. So stage number 1 is they don't apply the principle because they don't know how. Stage 2 is they figure it out and apply it everywhere. And then stage 3 is they learn when to not to apply the principle when it no longer makes sense. So what does this actually mean? So we call them principles, not rules, because they aren't perfect. You can give me pretty much, let me give my favorite example. So we have two very contradictory principles. So one of these principles is code to an interface. And the main goal here is to put it in basic terms, if you use many interfaces, then I should put a footnote, and DI, then your architecture becomes easy to change and test. So this is true. And then we have I don't like the name of this, we have the Yagni principle, which means you ain't gonna, that's beautiful English, you ain't gonna need it, is the Yagni principle. And that basically says if you don't need to abstract something out because you know it won't ever need to change, then it doesn't need to be if you don't need to abstract something out because then don't make extra work for yourself. So this is the situation with things in programming, and this is true of many disciplines in life, is that some of these principles are actually inherently contradictory to each other. And that's where things start to break down, is that when we first learn code to an interface, we try to apply it everywhere. And so that would be like, for example, stage 2. And then we get to the situation where we start to understand, well, actually, I don't need to apply it everywhere. Now, I actually really don't like Yagni, because here's the rebuttal to this concept, Yagni. You ain't gonna need it. Ah, come on. There we go. The rebuttal to this statement is until you do. So this is just kind of dumb statement because sometimes you do need it. So this is the opposite end of this spectrum essentially. And so this is kind of a dumb thing to say because you don't always need to code to an interface. So point being, these are rules, not, sorry, these are principles, not rules. Rules must be followed. Rules must be followed, whereas principles are there to guide our decisions. This is kind of the fundamental distinction here. So anyways, I wanted to just leave on that talking point. We're now 50 minutes into the episode, so I will stick around for plenty of Q&A. And thank you for listening and watching. Hopefully that was interesting to everyone. Just going to have a quick commercial break, drink some coffee, and if you learned something from all that rambling, then please hit the like button down below. That was a lot of talking. Okay, here we go. All right, let's get started with some Q&A. I realize that was a lot of talking, but you know, you guys know what you're signing up for when you watch this friggin' show. And I'm having a very bad hair day, I apologize. Not that anyone really cares about that. So, okay, so first question from Adrian. Adrian asks, do you prefer a new developer to start with MVP or MVVM, and why? So my answer is resoundingly, I highly suggest starting with MVP for the simple reason that it's less ambiguous to understand. However, I actually currently use a combination of several architectures in my production code, which is basically could be summed up as MVP plus VM. So I would suggest starting with Model View Presenter, and the reason why I suggest that is because Model View Presenter conforms to what I believe are sort of the three fundamental separations of the kind of code that you will be writing, with the understanding that there's kind of a fourth one, which is build logic. So we're talking about dependency injection. That's kind of the fourth layer I kind of don't like to talk about sometimes, but if we're kind of just limiting ourselves to three layers, there's three kinds of classes you will be writing in your career as a developer. And this is true of any application. Well, any GUI end user application. I should be a little more careful with how I'm speaking. So those three fundamental separations are so user interface or view, logic, so we could think presenter or controller. Actually, in the earlier stuff, I said decision maker. This is actually what I like to call these things now. I'll probably drop the term presenter and controller soon, and let me tell you, in about a year's time, I'm going to just stop using everyone else's silly words and just use my own silly words to describe these things. But for the time being, I'm not quite experienced enough to feel comfortable doing that. But I would just call it a decision maker. And then we have data. So this you can think of as model, if you've heard that term. So why do I think MVP is a little bit better than Model View View Model to learn? Well, there's a couple of things. In order to actually implement Model View View Model, just let me pull up another diagram. Where is it? So in order to actually understand how to do Model View View Model properly, you need to learn the observer pattern, which is demonstrated here. So whereas in a Model View Presenter setup, this box here would be called presenter, and this arrow here would point directly to the fragment, which is a simple way of saying they would know about each other, they would talk directly to each other, and that's how Model View Presenter can work, typically works. In Model View View Model, the view model exposes data to any view which is listening. So there are most certainly benefits to doing that, don't get me wrong. The problem is, oftentimes we do need some kind of decision-making process. Depending on how you build your application, there's ways to do it which don't necessarily need presenters. But for beginners, you're gonna be diving into some pretty deep water there. But yeah, you need to be able to understand how to use the observer pattern with live data, and this is just not something I would suggest for a beginner. It's kind of complicated. You do want to learn this, and you want to learn about Model View View Model, but I just don't think it's good for a beginner. Conversely, in Model View Presenter, it really is quite unambiguously just a distinction of you've got something which draws the user interface, you've got something which basically tells the user interface what to do, handles data responses from the model or the data layer, handles events and responses from the user interface. It's like the central control mechanism. And so if you can figure out a basic separation of concerns here between view and a decision maker for the front end and the back end, then you'll understand the main purpose of all of these architectures. Don't get wrapped up in Model View Presenter versus Model View View Model. The very sad thing about it is that these terms aren't actually as well defined as we would like to think. There's way too many ways to do Model View View Model. That's kind of my main criticism of it, is that it's not actually a strict pattern. The only identifiable characteristic I could find about a Model View View Model architecture is that you can never have a view model may never actually hold reference directly to a view, whereas in Model View Presenter, you are allowed to. So that's actually, in a nutshell, the only real distinguishing characteristic here that I could find. And this was actually, I thought I was maybe wrong about that, but someone pointed out that I believe Yeet Boyar and Chet Haas, I believe it was those two, they were on a podcast and they were talking about the new Android architecture components, and they were talking about choosing Model View View Model instead of Model View Presenter as their suggested architecture. And one of the things they mentioned about it is that they couldn't find a specific way to do it. So when I heard that from, some of the most famous developers on the platform, it was very vindicating, because I had exactly the same experience. I looked up one article, it told me to do this. I looked up another article, it told me to do this. And I really just got tired of the whole interpretation game. So anyways, hopefully that answers your question. So just to summarize really quickly, here we go, Windows 10 for the win. Just to summarize really quickly, I do suggest Model View Presenter if for no reason other than the fact that it's easier to understand and build. But MVM concepts from Model View View Model, this idea of the many-to-one ratio of views to view models, that's super cool. Look into all of them. but start with Model View Presenter in my opinion. And that's my answer. Let's see, what else have we got? So Saroj comments, please do some example of coroutines. I rambled a lot, so if I feel like it at the end of the show, then I can give you some more examples, but I want to just focus on questions for a moment. But I'll consider doing that. So my friend from Lithuania, Ementas Urbanus asks, do you know of some plugin for grouping / ordering folders in project view by logic? To answer your question, no. I think what you're talking about is if I open up well, I was going to say IntelliJ Android Studio here. I think what you're talking about is some way to get it so that these things aren't just alphabetically sorted here. Am I in? Yes, I'm in code mode. I don't really know of a plugin that can do that. This really doesn't answer your question, Ementas, but one thing I've really taken to doing is trying to avoid using the Project Explorer too much, and instead trying to use Control-N to find a class or Control-Shift-N to find a file. And I'm gonna drop a name here, but this was actually suggested to me by Jake Wharton, not directly, but this is actually something Jake mentioned is that's how he typically navigates a project. So I don't know if that's a feasible answer to your question or useful, but for everyone kind of watching, try not to rely too much on the Project Explorer unless you need to. Really, faster ways to just say, let's say for example, I want to open the result wrapper object. So I just really quickly hit Control-N, type res, and then there it is, hit enter, and boom, I'm at the file. That's a lot quicker than going, am I, which module? Okay, I'm in the domain module. Here, I'll use the keyboard, it'll be faster. Let's go to source, main, error, oops, sorry, that's not the one I want. Result. So yeah, it's not a huge difference, but like I say, consider using those the open file shortcut in IntelliJ or Android Studio. Pro tip. Okay, what else have we got? Okay, I will try and answer a question here. Babylon dem tief, my herb dem tief, my herb. Just singing some reggae. Okay, so Dr. Superblazer, I have no idea what that's referring to, says, I have just started learning Android right now, and I've understood retrofit architecture components. So I was looking for storing retrofit data in Room, and I can't understand the examples online because they need RxJava, Kotlin, and Dagger. So, oh, sorry, I forgot the actual question part. Okay. Let me just increase the font size. That feels a little bit small. Let's do that. Oh, that's too big, too big. How about 30? There we go. That's better. Okay, so Dr. Superblazer asks, so can I use, so Dr. Superblazer wants to store retrofit data in Room. And so why, so the question is like, shit, why do we need RxJava, Kotlin, and Dagger in order to do this? Okay, so here's the situation So what you're talking about doing, give me a minute. Where's my marker? Oh no, I think I'm missing my marker. I was gonna bust out the old whiteboard, but yeah, I don't have my marker and I'm all wired up here. Text will have to suffice. So here's the problem. So in essence, the problem you're dealing with is coordinating multiple back-end services. So when I say services, oops, this is just like a catch-all word for database, system service, retrofit, just back-end stuff. So just so there's no ambiguity to what I'm saying here. In essence, the problem you're dealing with is coordinating multiple back-end services in order for the app to function correctly. So what I mean by that is you said very specifically, so you want to get some data from retrofit, and then you want to store it in room. So RxJava is, and you don't need RxJava for this. Let me deal with a couple of things. So to answer this part of the question, can you do this without RxJava, Kotlin, and Dagger? You certainly can do it without Dagger. If you're going to not use Dagger, what I would really suggest, Dr. Superblazer, is look up, again, this is Kotlin, so it might not be the easiest thing. If you're not going to use Dagger, because admittedly it's hell to work with, am I in the right thing here? Where's my injection? Is that it? Here it is. Okay, if you're not going to use Dagger 2, I would suggest you try to have some kind of manual handwritten dependency injection. But like I say, here's the thing. You don't need to do that, but it is advisable. And the reason why is that you need to be very careful that you don't have situations where you have multiple instances of, say, a retrofit API and then multiple instances of, say, a room database, which shouldn't actually be possible because a room gets built through its own special stuff. But, you know, that's the general idea. Also, if you apply dependency injection, which again, you don't have to do it Dagger 2 style, you can handwrite it like that, then you're easier able to test your application, which is something you may or may not care about. You don't need Kotlin to do it, certainly not. I think I'll share a resource with you in Java, which should help you solve this problem. And you don't necessarily need RxJava. Here's the deal. If you don't want to use Kotlin, I would suggest using RxJava 2. You can handle concurrency using what are they called? Executors /threads. So you can handle it kind of manually. But I actually think RxJava is a better solution for Java. It essentially what you're going to be writing with it is the code necessary to take in a source from, say, one service and another service. So they both call back with some response, and then we handle that response, and then we decide what to do from there. And RxJava is great at coordinating multiple different services or even the front end. RxJava is really cool because you can basically start to do reactive programming. That's a very big topic to unpack here, but yeah, anyways, I'm kind of going all over the place. You don't need to use RxJava 2. I would suggest it if you're using Java. If you do Kotlin, you don't need RxJava at all. Use Coroutines. Everyone, please consider using Coroutines instead of RxJava if you're working in pure Kotlin projects, because that's one less third-party API, and they are a lot easier on the eyes than RxJava if you get them configured properly. So yeah, basically to answer your question, you don't need any of these particular things. You probably want to use some of them because that's just the way that we typically do things in the industry. Now let me show you a project which should help you get some bearing on what you need to do if you want a Java sample and you don't want to use RxJava and so forth. The problem is, so here's the important thing about this, my righteous friend. You still need to handle concurrency. Room, as you probably are aware, and retrofit, they're asynchronous data sources. You have to coordinate those, and you're going to have to do that. You can do it with RxJava, you can do it with Coroutines, you can do it in Kotlin, you can do it in Java. The problem is if you don't want to use RxJava or Coroutines, you're going to have to find some other way of doing it. So you'll get kind of a lower level solution. So you might learn lots doing that. But yeah, there's no easy answer, unfortunately. Anyways, let me find that. Just give me a moment here. Okay, so what I'm going to suggest to you is check out this repository here. So this is, oops, I'm on someone's fork of it actually. So this is Google Samples / Android Architecture. These are all open source projects, repositories. And if you navigate, so these are stable Java samples. So these will give you the code you need to build what you want to build. And they do actually often demonstrate coordinating a local and a remote data source, which is the same thing as what you're trying to do. You've got a retrofit, a remote data source, and then you've got room, which is a local data source. So all you really need to do, my friend, is just hop into this repository and study this. This one is a pure Java example, and they use, if I recall correctly, executors instead of RxJava. And it's model view presenter, so it's pretty easy to understand. So if where do we have this thing? Do we use executors? I haven't actually looked at this code much, so what it do? What it do, man? That's an interface. Huh. Well, you know, I'd have to look at it. I'm pretty sure somewhere in here they use friggin' executors to manage this stuff, but let's just look really quickly. Where the... I know it's here somewhere. Just give me a minute. No. I swear they used friggin' app executors in this thing. Maybe I'm totally mixed up. Yeah, this is the thing I was talking about. And so this is basically the more vanilla equivalent of RxJava. So this isn't actually that's actually an incorrect statement. This is just app executors. So this is just being able to execute operations asynchronously. So you'll have to set up something like that. Anyways, check out that repository. this one here, Android Architecture Blueprints. It's friggin' amazing. All right, let's get to another question. And of course, I love it when YouTube chat loses my place in the comment section because it's updated. All right. Taha comments that I further screwed up my workout interactor again. I'm sure you're correct, my friend. Yep, I think he's commenting that I made the same mistake as before. Which, let's see, workout. Workout interactor. Oh, you mean here? Yeah. No, yeah. It's okay. I will run into plenty of errors. Don't worry about it. But you are absolutely right. That was the original error I made. I can kind of answer that question, a non-technical question. I'm going to call you Only. Only asks, dude, is there jobs for Android developers in Canada? So, yes. If you live in Vancouver, Victoria, where I live, I think Calgary has a bit of a scene going on, and then maybe Toronto and Ottawa, and then certainly in Montreal. Those are kind of the main tech capitals for Canada, as far as I'm aware. And there are jobs for Android developers. Most likely you will get a job with a startup that requires some kind of Android developer. If you're good and lucky, you can get in a bigger company, but that's not really something that's ever appealed to me. But yes, absolutely. There are jobs for Android developers in Canada. Okay, a bunch of, let's get some rapid fire questions here. I'm just not even, yeah. I'm just gonna call you someone. No offense, but you know, whatever. So someone asks, do you think that the future of mobile development will have most people using simplified, robust frameworks like React plus Bootstrap? So I've answered this question multiple times in different forms. I'm just going to give you a really brief summary of it. But yes, over time, it will make less and less sense to have a native operating system on handheld devices. Over time, as internet bandwidth improves and there's less latency between when I hit a button and a signal is sent to a cloud server and vice versa, it will make less and less sense to do computations on these things, and instead these things will basically just become renderers of views, and most likely they will just have a browser and then some kind of graphics card. If it's a browser, it's probably going to be JavaScript based. There's unfortunately a good possibility of that. So I don't think native development will disappear super soon, but certainly in the next 5 to 10 years, I highly doubt I will be an Android developer. Even if I wanted to just be one, which I am interested in far more than just Android, but yeah. Anyways, so that's that. Do I advise to, so this is a follow-up from Only. Okay, so question is, should someone learn Flutter? I think the kind of nested question is, should you do Flutter instead of Android? So listen, I'm not on board the Flutter train yet. It's still a very I haven't written code in Dart and Flutter. I have my reservations about the fact that it compiles to JavaScript instead of the JVM. There's just, listen, there's reasons why I don't hate the idea of Flutter in principle because it's its own kind of operating system and SDK. The problem with it is there's plenty of good reasons to stick with the JVM-based operating systems, mainly due to the fact that I believe Java is still the most common programming language that code is written in, and I don't think the power of the JVM, which Kotlin compiles to, which is actually what I'll be working on instead of Flutter, is using Kotlin, like Kotlin. I'm going to test this out. I might eventually switch to Flutter, but for now I'm just going to look at Kotlin JS as opposed to Flutter, and I'm going to keep my lovely, wonderful coroutines and Java stdlib and all those things that I really love about coding in Kotlin and Java, which the thing about Flutter is you're going to be pretty dependent on their developers to implement features. It doesn't have a mature code base of plugins as far as I'm aware. And that's basically all I really want to say about this. I'm not on board the Flutter hype train yet, but we'll see how it goes in a couple of years. But if you're concerned that if you learn Android, you're just suddenly going to become an obsolete developer, don't look at it like that way at all. Maybe I would kind of suggest people learn Kotlin over Java at this point, but even if you learn Java, you're still going to improve your skills as a developer. You're still going to be very useful, so I wouldn't worry about it too much. With that being said, don't learn things based on what I tell you to learn. Explore things that interest you. So if you're really interested in Dart or Flutter, learn it. Don't not learn it because I have my biases against it. What else have we got? Okay, I can. We're getting close to the end of the show, so I'm gonna probably just do 2 more questions. I have a lot of them, so just give me a moment to be a bit selective here, and I'll just run a quick commercial break. Oh, wow. Okay. Oh, still running the ad. Okay, so we're back, and I'm just going to do 2 more questions. So one of these questions is quite technical, and one of these questions is very not technical. So we'll just finish off with those 2. So another question from Adrian. So what are some good resources for learning Kotlin for Android? Honestly, so I would suggest, here's what I would suggest. So check out Google's Code Labs for Android / Kotlin. Excuse me. Code Labs are great. Check out these Google repositories. These are open source code bases which you can learn from. So that's going to be Google samples / Android architecture. I actually showed everyone that one earlier. Just Google Android architecture blueprints and you should find it. And then there's also Here, let's do this way. I guess my face is probably blocking that. Then we also have Google samples slash, I think it's Android architecture. Oh, I'm having such a hard time typing today. Android architecture components. So these two are full of wonderful open source code, which will help you learn how to actually build applications in code instead of having to rely too much on external resources. The code labs are great if you do kind of want a lesson-based thing. I have my own content. So for example, the way I sort of generally advise beginners try to build applications is based on Kotlin MVB calculator. So link in the description box below, and my GitHub is bracket cove. Oops. So you can check that one out on GitHub as well. And so those are my main resources. I'm kind of writing a book on Kotlin, so at some point I'll be able to suggest that as well if it ever comes to fruition. But there's that too. And those are the main things. This is really all you need to learn Kotlin. Lastly, another thing, watch Kotlin conference videos, especially what's his name? Roman Eliezeroff? Or is it Razov? Crap. I don't know. I do not remember Russian name. Give me one moment. One moment. Eliezeroff. Okay, I didn't actually get it correct. So this guy is on the Kotlin team, and he did a bunch of talks on coroutines, and he basically explains, so coroutines are, it's not easy. When you start with coroutines, it's really going to kind of mess with your brain a bit. Once you actually understand how coroutines work, which is a complicated process, he does an introduction video and a more complicated video. I watched those videos several times and studied them intensely, and that's how I was able to figure out coroutines. Lastly, there is the coroutines guide, which is another GitHub repository. Here, big surprise, it's by my friend here, but I don't actually know him, but what an awesome dude, Roman. And this will be your source of truth when it comes to implementing coroutines. Now, I don't think this thing can be a bit difficult because it shows you like code snippets, which is a little more difficult once you want to understand how to actually build these things in the whole application. But that's a really great resource as well. And you can find that here at this repository up here. And so those would be my main resources. And then, so that was your first question. And then you're asking, what is the difference between RxJava and coroutines? So let's just briefly talk about this. So RxJava 2. So in a nutshell, RxJava 2 is a very high-powered implementation of the observer pattern. So the observer pattern basically, in a nutshell, means that you either have you look at your entire system basically as either being composed of subscribers, or subjects. Again, if you learn RxJava, you're going to get to dive headfirst into the functional community's naming conventions, and they really suck at naming things. I'm just going to kind of go out and say that. As much as I love functional programming and it's wonderful, things like RxJava, you know, you're going to see just a whole bunch of words that mean the same fucking thing, and it's going to be really annoying to learn, but that's just how people teach RxJava. So, yeah. So RxJava is a high-powered implementation of the observer pattern, which also allows concurrency threading to be handled easily. So what is RxJava in a nutshell? It's basically, let's go to POS Trainer. So this is what you're going to get if you're coding in RxJava. You're going to have different parts of your application. So what could I do? How can I demonstrate this? Let's go here. So how RxJava works is each of these different parts of your system, so let's say the backend, if you're using clean architecture, maybe like a use case or an interactor, but basically from the front end to the back end of your whole application, you represent it as an event stream. An event stream is defined by objects, which are either, again, let's do some more jargon terms. Producers, this is the same thing as subscribers and subjects. I should have used this term instead. Producers and consumers, or both, just to make things complicated. The things in the middle of your architecture will usually be both a producer and a consumer. So what does RxJava look like? You basically return, the way I want you to think of it honestly is you connect these tubes, these pipes, to these different, let's represent it this way. With RxJava, you create these tubes between the different parts of your application, and data can travel through the tubes. So what does that kind of mean? When you get to the actual code, all of this crap here, all of this is basically creating a tube which this bit of data here, whatever data you want, travels through. When the data travels through the tube, it pops up in, say, onNext or onError or onComplete or whatever RxJava thing you're using. And so that's the basic gist of it. If I go to get alarm, the use case, let's see, I'll just go to any use case, doesn't matter. You'll see it returns, say, some kind of observable or a completable or some kind of tube, essentially. It's impossible to explain this because of the stupid jargon. I apologize, but yeah, let's put it this way. This is what RxJava looks like. The main difference is that RxJava 2 uses CPS, continuation passing style. What is this? Continuation passing style. I mean exactly this thing. RxJava uses callbacks. Continuation passing style is a big fancy word for callbacks, such as anonymous callbacks in an anonymous class here. Okay, happy? What does Kotlin Coroutines do instead? So, for starters, Kotlin Coroutines. So coroutines aren't necessarily aren't the observer pattern fundamentally. They can be kind of used to implement it in a sense, but Kotlin actually has its own delegated property for an observer. Kotlin Coroutines, sorry, I should jump back here. RxJava allows you to coordinate multiple different asynchronous sources together in this big, ugly friggin' chain. And it uses callbacks when you want to get the data out of the RxJava stuff. Coroutines don't do that fundamentally. Coroutines coroutines are designed to handle concurrency from asynchronous sources. So we're talking about callbacks from a database, callbacks from a network tool, callbacks from a system service. So they do that, but they allow you to write your code in direct style. So direct style does not have callbacks. So let me just show you. I'll shut up for a minute and let me just show you what it looks like. This is what RxJava looks like. You return some kind of observable or flowable, or whatever jargon word you want to use, whichever API you want to talk about. You return it, you tell it what to, brain fart, you tell it which thread to perform the calculation on, or the IO operation. So this is the IO thread. You tell it what thread to listen on. So basically, when you want to return some backend operation, then you tell it, hey, I want this backend result to pop up on the UI thread, because we're going to be updating the UI, of course, the main thread. And then this is where you actually handle the response that you get from your backend service. In Coroutines, this is exactly the same thing, basically. I'm calling a use case. Same thing. Same thing, really the same thing. Don't get confused here. But wait a minute, where's all that boilerplate crap? Why don't I have to do all this stuff? Because of coroutines. It calls this asynchronous method, and because it's a suspension point, a coroutine, it's going to wait for this to work asynchronously. It's not going to block the main thread, and it's going to, I can write this, instead of having to call back for this result to have some big ass, I don't even want to bother drawing it here, but to have some big ass callback thing here, I just call the bloody method, check what result it is, and then handle things appropriately. And I don't even need, like, as you can see, we've got on error, we've got on next, on complete. With coroutines, if you use a result wrapper object, you can represent those callbacks in direct style here. So this would be on error equivalent, or actually this would be non-fatal error equivalent, and then this would be like the equivalent to on next. So as you can see here, in that on next type thing, we update the user interface by updating the view model. And then if there's an error, we do the same thing, except we just display an error message. And yeah, so what I'm basically saying here is coroutines allows you to write something that looks like, this, when in RxJava, you used to have to write it like this. So now you might kind of see why, oh my God, I've been talking for 5 minutes and I didn't realize I wasn't in code view. I am so sorry. That was really stupid. Oh, I hate it when I do that. I'm an idiot. Sorry, everyone. One of these days I'll learn. Let me just summarize it really quickly again. I think I just spoke for like 5 minutes and was trying to show you all the code, and it was just me in full cam whore mode. I apologize about that. In a nutshell, oh, that's such a fail. In a nutshell, this is how you would write something with RxJava. You've got all of this boilerplate, and you've got a callback here. And this is how I write essentially the same thing with coroutines. So no callback, it's written in direct style, and I don't even need to bother with on error, on complete, all of that crap. I just have an object which is capable of representing an error state and a success state, and then look at that. Super easy. And we don't have to go insane about tearing our friggin' eyeballs out, depending on whether I want to return a flowable or an observable or a completable or a single, and whether it's called a consumer or a subscriber or an event producer or an observable or an observer or a subject. All of that annoying, my least favorite thing about reactive programming, we can skip a lot of that crap. So anyways, oh, you actually did see the code. Oh, sweet Jesus. Oh, I'm so happy about that. I don't know how I screwed that up then, but that scared the hell out of me. Okay. Sorry, Ameth. No matter how many times you say please, I will not show you a Dagger 2 implementation this late into the show. But maybe if you ask, you're going to want to check the older episodes because I do talk about it quite a bit. Okay, there was one more question which wasn't technical in nature, and let's cover that one. But yeah, so Kotlin, Coroutines, and RxJava can be used to achieve the same thing in a sense, but they are different, and I prefer Coroutines if you're working in Kotlin. If you're working in Java, I would still advise using RxJava, or let me rephrase that. I still like to use RxJava, as much as I just crapped on it. Okay, one more question. Here we go. Oh. Okay, so it's a long question, so I'm not going to copy and paste the whole thing. Instead, I'll just kind of do my own paraphrasing. So Dario asks, just give me a moment to parse this. Okay, I'm going to kind of paraphrase this. So Dario is working for a pretty garbage, I shouldn't say it like that, is working for a company which has an extreme preference for quantity and speed in exchange for quality and long-term stability when it comes to their code bases. So basically what I'm gathering from Dario is that presumably, I'm assuming your gender, but presumably he, apologies, I'll just say your name actually, that's easier. Dario is working in a company and where from the sounds of the comments, from the sound of what I'm reading here, they don't use any design patterns. Let's listen this out. They don't use any industry standard libraries, so that's a problem. They don't apply any design patterns. That's a problem. There's a ton of useless and duplicated code, and they are building upon what is known as the big ball of mud architecture, which means they don't have an architecture. They just keep slapping new features into this ugly mass of code that's probably breaking all the time, and they have no idea why. Dario's words, not my own. So the question Dario asks is, that's not the question, that's coroutine stuff. So this is Dario's question. Is it time to move to next company where I can develop my skills faster and learn the right way to build applications? This is obviously going to be a more opinion, open-ended question. What I would suggest to you is to basically, here's the thing. I think you're right to consider quitting and moving to a company where you'll be working with better developers and learning new things. I think you're absolutely right about that. So I do think you shouldn't stick to this company. Maybe what you should do is, if you're having success learning industry standard libraries and design patterns and being a better developer, maybe consider introducing some of that stuff. I think you said you're a junior developer. Is that correct? Yeah. Well, I don't know. Maybe if you're able to convince them while you're there to start using some better practices, then ask for a raise. Here is how I would, I won't tell you what to do because I don't know, and only you know best what you should do. But here is how I would evaluate the situation if I was in your particular position. I would purely look at the value. So do you have, so for starters, do you have another option set up? So I wouldn't quit necessarily unless you either have a lot of money put away, several months expenses put away, or you've just been accepted in a new company. So I wouldn't quit. I would certainly advise looking for a new company, absolutely. And you don't have to feel bad about that. That's one thing I used to be quite, I'm not saying you're dealing with this, but when I was younger, I used to care a little bit too much about making my employers happy. At the end of the day, you really got to watch out for yourself, especially in this industry, because the last time I attempted to actually work as an Android developer in a company, I almost got screwed over in so many ways I can't even describe it to you. The contract they wanted me to sign, I won't give any details about the company itself, but the contract they wanted me to sign basically would have given them ownership over all of my wise-ass projects and every line of code I write while I'm working there, which suffice it to say I turned the job down. So always watch out for yourself. Yeah, that's basically it. Yes, I do think you should, as soon as it is a good value-based decision to move to another company, you certainly should. I can't tell you how amazing it is for me, for example, to have the opportunity to chat with and work with my friend Darrell and my friend Davor on code projects. And the wonderful thing about being in a company or a team with people who actually care about building good code is you guys will all push each other to do things better and better and better. So it is very much worth working in a company around people who are as good or better than you, instead of working in a company where the emphasis is on, let's just ship the code and then hope the client signs the check. Who cares what the architecture is? I don't need architecture to make money. So yeah, that's my opinion there. Anyways, that's basically it. No way. No way. No way. Okay, if this is actually true, so this is something, this is a follow-up from Dario says, I tried to introduce design patterns and they refused. They said you can achieve the same thing in one class and a few if-else. Listen, Dario, you need to leave this company because you're among people who don't understand their own craft. So use them if you need to make money, if you need to make connections, and you need to improve your resume. But listen, if you've got people saying that design patterns can be, the same thing can be achieved in a single class and a few if-else statements, if that's truly what they said, then you're talking to idiots. Incompetent idiots. Like, seriously, yeah, you can, listen, there's an Android application out there which has like hundreds of millions of users. I forget the name of it, and it's basically comprised of a couple different activities. So these activities have like tens of thousands of lines of code, and it's basically the end result of this attitude. By the time, listen, you can make a ton of money building an absolutely terrible app. You, as a developer, I would suggest, will benefit far better from learning how to build great applications, which will open doors to you so that you can work with better companies, make even more money, and be even more happy with yourself that you're building great things, instead of just trying to build things the quickest and poorest way possible. Because the problem with building things quickly and poorly is that they rapidly become unmaintainable. That's it for today. Thank you so much for watching, and I hope everyone has a good Sunday. So, anyways, that's basically it. Peace out, everyone.